Okay. Assalamualaikum and salam sejahtera. So today we will continue to the next subtopic of first order differential equation, which is exact equation, which is the exact equation. So before that, how we want to identify what is exact equation? So suppose that f(xy) is equal to negative mxy over nxy. Therefore, the first order dE is given by dy over dx equal to negative mxy over nxy. So how we to get this one? The second equation, you cross product this equation. So you will get mxy dx plus nxy dy equal to 0. And this m you consider as delta u over delta x, and n is considered as delta u over delta y. Okay, so next, the important part is the condition for an exact equation is the value of delta m over delta y is equal to delta n over delta x. The value must be equal. Okay, and then there are two methods of solution. So we go to the first method, where the first method here is we write the dE in the form of mxy dx plus nxy dy. And then test the exactness, where you should get delta m over delta y is equal to delta m over delta n over delta x. If the dE is exact, then m is equal to delta u over delta x, n is equal to delta u over delta y for equation 1 and 2. To find u from 1, we integrate 1 with respect to x. So ux is equal to integrate mxy dx plus phi y. That is equation 3. And to determine phi, we differentiate 3 with respect to y. And then after that, you can get the phi y. You can compare the value there. And you integrate delta phi prime to get the phi y and replace phi y into 3. Okay, and then if there is any initial conditions given, substitute the condition into the solution. And then after that, the last one, you can get the solution of u is equal to a, where a is a constant. And the second method is, this is the second method solution for the second method. Similar, write dE in the form of mxy plus nxy and test the exactness. Delta m over delta y is equal to delta n over delta x. If the dE is exact, so your m is equal to delta u over delta x and n is equal to delta u over delta y. And to find your u from m, integrate 1. You get your m here. And from n, you need to integrate number 2 for n here. Okay, and then after that, you compare the equation 3 and 4 to get the value of phi 1 and phi 2. Replace phi 1 into 3 or phi 2 into 4. Okay, and then after that, if there is similar to the previous method, if there is any initial condition given, you can substitute to get the solution. Okay, these are the example 1. Solve 2xy plus 3 dx plus x squared minus 1 dy. Okay, the first method is, the first option is you need to, well, the first step is you need to check the exactness. So this is your m and that is your n. You identify which is your m and which one is your n. So this is your n, this is your n, and you differentiate, find the partial, so you get 2x, delta n over delta x, you will get 2x. So this equal, and that is exact. Okay, and then after that, you let delta u over delta x is equal to 2xy plus 3, and delta u over delta y is equal to x squared minus 1. And you integrate 1 with respect to x. You integrate 1 with respect to x, so you will get x squared y plus 3y plus vy. Okay, and then your delta u over delta y is equal to x squared minus 1. So you compare with 2. So from here, we can see that your vy is equal to -1 if you compare both equations here. Phi prime y is equal to -1. So you want to find your vy, so you need to integrate phi prime y. Integrate phi prime y, where your prime y is equal to -1. You do the substitution, and then you can get y here. And you write down, uy is uxy is equal to a. So what is your uxy? This one, x squared y plus 3x minus y equal to a. And then you factorize your y. There are 2y here, you factorize. Here you get y, x squared minus 1 plus 3x is equal to a. So your y is equal to a minus 3x over x squared minus 2. That is your final answer. That is for that example. We go to, we try to solve example 1 by using method 2, where this is your delta u over delta x, delta u over delta y, a and b. Integrate a with respect to x, so you will get x squared y plus 3x plus vy. And then integrate b with respect to y, so we get x squared y minus y plus phi y. Phi x. Okay, and then after that, you compare 1 and 2. You compare 1 and 2, x squared y plus 3x plus vy is equal to x squared y minus y plus vx. Okay, and then by comparing this one, you can see that your phi x here is 3x, you compare, and y is -y by comparing the value, the term. So uxy is equal to x squared y plus 3x minus vy is equal to -y. Use the substitution, and uxy equal to a. So you can get x squared y plus 3x minus y is equal to a. That is if you are using the second method. Okay. Okay, and then after that, this is the example 2. Show that xy plus y squared plus y dx plus bracket x plus 2y dy is equal to 0 is exact. Okay, so we need to show that is exact. So this is your m, and this is your n. The left hand side is your m, and this is your n. By multiply, then there is another one. Then multiply both sides with the integrating factor of mu is equal to exponent x. Solve the equation. So the first question is, we need to check, and we need to show that this equation is exact. So your m is equal to x y plus y squared plus y. So you need to find delta m over delta y. You need to differentiate with respect to y. So you get x plus 2y plus 1. And your n is equal to x plus 2y. So your n, you differentiate with respect to x, you will get 1. So this is not exact. So because that is not equal, and then you multiply with mu, where mu is exponent x. So multiply with mu, you will get exponent x times with all the equation here. So you will get exponent x times with xy plus exponent y, y squared plus y, and delta m over delta y is equal to exponent x plus 2y plus 1, and this one you differentiate with respect to x. So this is your v, and this is your you need to expand. You can expand, or you want to do the product rule. So you can get x plus 2y exponent x plus exponent x. So from here we can see that this is a similar amount, exact amount. So that equation is exact. Okay, and then this is your delta u over delta x and delta u over delta y. You have both delta u over delta x and delta u over delta y. Okay, and then after that, you integrate. This is more easier to integrate, to do the integration. You integrate exponent x plus 2y dy, and then you can get this one, exponent x xy plus y squared plus phi x plus phi x. So delta u over delta x is equal to, you need to differentiate with respect to x, this equation. So you get exponent x y plus xy plus y squared exponent x plus phi prime x. Okay, and then after that you factorize. We factorize, we get this term. So compare delta u with delta x. Delta u, the first one here, delta u compared with what you have get here. This is what you do the comparing. So we can see from here that phi prime x is equal to 0 because all have the partner here. But so this one phi prime x is equal to 0. So if you integrate 0, the value is constant, any numbers. So you can get your u xy is equal to exponent x y squared plus xy is equal to k. So we write the final answer. U xy is equal to a. So this one, your u equal to a, and you can put your k to the left hand side, so you can get a minus k. This is a constant, so you can let a minus k is c. You can let to simplify the equation. So that's why we put c here, or any other variables. Okay, and then that is your final answer. So these are the questions from the past year test 1. So you can try later for your understanding. And you can study from the textbook. There are lots of other examples for you to study. Okay, so that is for the exact equation. So I think that's all for this video. For the next subtopic, which is linear equation, we'll continue for the next video. Okay, thank you. Stay tuned. Bye. Bye.